Now moving on, let us understand the vocabulary discrete variable. Now this is nothing but a variable that represents a countable quantity. Now the best example for this is employees in an organization. This is the example. Employees in an organization, or students in a class, say students in grade 8, something like that. Now next comes continuous variable. This is a variable that represents uncountable values. A variable that represents uncountable values. Now what is the meaning of this? The meaning is you wouldn't be able to clearly pinpoint the quantity in an absolute fashion. Like for example, if I were to ask you, can you tell me the number of employees in an organization? Clearly you will give a definite answer. But that is not going to be possible in case of continuous variable. Example, length of a river. Right? It's not actually possible to clearly define with one particular quantity that this is going to be the length of a river. That's not going to be happening. And similarly, the height of a person. Height of a person. Of course, we would give a range, right? Often we will give a range, often falling within a range. So whenever we have continuous variable, we will adopt this process of studying this variable. Okay, so much so for the variable. Now let us move on. Next is what is called as nominal scale. You have to know this term. It's a very important term. So this is nothing but a scale used for labeling variables without any quantitative value. So if you are dealing with a variable which has to be studied and which cannot be defined with a quantitative value, then we use this nominal scale. Of course, as we move on, I will give illustrations for each and every term that we are studying here. Example, say color of the eye, color of the air. So these are all some of the examples. So you wouldn't be able to measure them using a quantitative value. So in cases like that, we use nominal scale. Next comes ordinal scale. So what is an ordinal scale? This is a scale used for variables with a clear ordering, but without a clear distance between them. Without a clear distance between them. Example, the best example in this case is the education level of an individual. So moving on, we got two more to go. this is also very important. This is called as interval scale. Now don't worry, I would be giving illustrations for each and every term that we are coming across. This is a scale used for variables with clear ordering, and a clear distance between the values. So in this case, a scale used for variables with a clear ordering but without a clear distance. Now in this case, a scale used for variables with a clear ordering and a clear distance between the values. Now the best example would be temperature measured. Example, temperature measured in Celsius or in Fahrenheit. Now after the interval scale, we have got the next scale, what is called as the ratio scale. So a scale used for variables with clear ordering, a clear distance between the values, and a true 0 point. Example, height of individual. So much so for the definitions of these variables. Next, we need to know what is the mean. This is the most common definition. This is nothing but the average value of a data set. This is found by adding all the values and dividing by the number of values. Now the next comes median. Now people will be confused between mean and median, but I am going to give you illustrations that will enable you to understand the median. So this is nothing but the middle value of a data set which separates the higher half from the lower half. Now next comes mode. What is mode? Mode is the value that is most frequented in a data set. So this is the value that occurs most popularly. Next, you have to know range. Let me fit that range here. Range, the difference between the largest and the smallest value. Largest and the smallest value in the data set. Now after the term range, we got what is called as the standard deviation. Now let me go to the next page and give the term standard, very important concept, standard deviation. Now what is standard deviation? This is a quantity. You can use the word measure. It's a measure of the amount of variation. You can use the word variation or dispersion. This term will also be used, so don't get intimidated. Either variation or dispersion in a set of values. So this is the important definition. A measure, so you give a value, and that value would indicate the amount of fluctuation that is present in the data set. So when I say fluctuation, each of the values present in the data set would differ by that amount, either that amount or around that amount. Okay, so that is the reason we say standard deviation. Standard, so standard means universally, right? Universally there is a quantity that would actually represent the dispersion of each of the values present in the data set. Now this could be better understood only when we do a problem. So problems are important. Now next comes variance. So what is the variance? The average of the squared differences the average of the squared differences from the mean. So if you are taking the difference from the mean and you are taking the square of it and you are calculating for each of the data elements or data present in the data set and you are taking the average of it, that is going to be giving us the variance. Okay, so we are actually doing a good job by learning all of these vocabularies. Now next comes correlation. So what is correlation? It's a measure. Now this is actually a measure of the relationship between variables. Relationship between two variables. So it's a measure. That means you are actually going to be working out this important measure. So once you get this measure, that would be the correlation that is existing between the variables that we are studying or we are on the lookout for. So the term correlation itself gives us the meaning. Okay, the next is the all important term called regression. Now, this is a very important term, regression. This is nothing but a method, right? This is not a measure, but it's a method to model and to analyze the relationship between variables. So in this case we are actually analyzing the relationship between variables. In this case we are only giving a measure for the relationship between variables. In this case we are going further to analyze the relationship between variables. So having given you that, next is what is called as hypothesis testing. Hypothesis testing. This is a very important term. Now, what is this? This is nothing but a method to test if a statement, when you say statement, it can be an assumption, a statement about a population. Statement about a population. Now the important word is parameter. So when we talk about parameter, we are talking about the variable. So a method to test if a statement about a population parameter is correct or not. So as I mentioned to you, we will do questions related to all of these terms, because only when we work out these things we would be in a better position to understand. Next comes the all important p-value. So what is that? This is nothing but a measure that helps us to determine the evidence against null hypothesis, against a null hypothesis. So when we talk about null hypothesis, this is the hypothesis by default we assume, and p-value gives us a measure that helps us to determine the evidence against this null hypothesis. This is a very interesting term. Now we will have to learn about probability. That is also important. Some terms regarding probability I wish to give. So I'll start with probability. Now what do you mean by the term probability? It is nothing but a measure of the likelihood of a particular outcome. So when you say outcome, it can be an event also occurring, event or outcome occurring. So what is the probability that tomorrow there is going to be sunshine? So that is the measure. You can give 50% chance or 60% chance. So that is with regard to percentage. But when we talk about probability, we will assign a quantity, we'll assign a number, a numeric value. So having given you that definition of probability, let us go and study or understand what exactly is probability distribution. This is very important when it comes to machine language or data sciences. So this is nothing but a function that describes the likelihood of obtaining the possible values that a random variable can take. So after probability distribution comes normal distribution. So what exactly is normal distribution? Now I know I am exhaustive in giving you these vocabularies, but after giving you these vocabularies I will further categorize them into groups, and then I will give illustrations in the form of problems so that you can understand each of these. Okay, so coming to normal distribution, it's nothing but a symmetric bell-shaped curve. That's an all-important curve. Bell-shaped distribution. Okay, I'm using the word distribution. Characterized by its mean and standard deviation. STD stands for standard deviation. So what is normal distribution? A symmetric bell-shaped distribution characterized by its mean and standard deviation. The next all-important thing is you need to know what do you mean by sample size. Okay, so let me give sample size. So what is it? It's nothing but the number of observations in a sample. Straightforward, number of observations present inside a sample. Now whenever you are dealing with probability, you've got margin of error. In fact, whenever you're dealing with any form of statistics, there is a margin of error. So how do you define it? It's nothing but the range within which the true population parameter, that's a variable, is expected to fall. based on the sample data. Now next is central limit theorem, the all important central limit theorem. Without this we wouldn't be able to do many of the things. Okay, let me just stop there. LIMIT, limit theorem. So I will again do questions related to central limit theorem for your understanding. Now what is this? This is nothing but a statistical, okay, theory that states that given sufficiently, see the beauty of this theorem, sufficiently large sample size, the sampling distribution of the mean will be approximately normally distributed. To get this is all important, a normal distribution. Regardless of the population's distribution. Now this theorem, central limit theorem itself, is a great philosophy, right? So when we study the central limit theorem, when we do problems related to that, I will give you an enlightenment into the philosophical details that this great theorem conveys. Okay, so next final terminology that we need to know is called as the z-score. So let me write that down, z-score, or it's called as the standard score. Now what is this? I hope you're able to watch this. A statistical measurement that describes a values relation to the mean of a group of values. Let me write that down. A statistical measurement, so very important, z-scores, that describes a values relation to the mean of a group of values. So it is a statistical measurement that describes a values relationship to the mean of the group of values. Okay, so I know we have done quite a bit of terminologies, but don't worry, I am going to give you related questions and solutions for each of this. Now if you know these terminologies, you are good to go. You can handle any level of questions related to statistics, and not only that, you can also study my Python course where I have connected statistics and Python. Now as I mentioned to you in the previous lesson, let me move to the next page. I started to differentiate statistics. Right, now what did I do? I mentioned clearly that there are two branches of statistics. One is theoretical statistics and another is applied statistics. In applied statistics, we are going to be looking into descriptive and inferential statistics. Right, descriptive and inferential. Just now I have given you many terms. Now as I mentioned to you, when you talk about descriptive statistics, you are trying to understand what the data is conveying. Have that in mind. In case of inferential statistics, you are trying to forecast, you are trying to make a prophecy, that's a better word. a prediction. Here you're trying to understand what the data is telling you, or what the data, how the data is behaving. This is more like understanding for the action or for the result that has occurred. Say for example, Usain Bolt wins the 100-meter race, and you are studying his performance in the last 30 races that he has run. So definitely there is a data associated with that. And today he wins. Now with these information, with the data that you have on Usain Bolt in the past 30 races, you would be able to clearly understand why Usain Bolt won this 100 meters. So air of understanding is obtained. Most times descriptive statistics is all about providing a measure, a value, a quantitative value would be given, or I should say inferential statistics. We take in the given set of conditions and we actually predict. So have that differentiation in mind. Okay, so having given you that, let me put in the vocabularies that we have studied. Let me categorize them. So we talked about data. That falls under descriptive statistics, and population, sample, variable. I hope you are able to see it. Variable, all of these things fall under descriptive statistics. Categorical variable, quantitative variable, discrete variable, continuous variable, nominal scale, ordinal scale, interval scale, ratio scale, mean, median, mode, range, standard deviation, variance. That's it. So all of these things, they come under descriptive statistics. Now inferential statistics, correlation, regression, hypothesis testing, p-value, confidence interval, probability, probability distribution, nominal distribution, sample size, margin of error, central limit theorem, z-score. That's it. Z-score is also called a standard score. Standard score. Okay, so I have not only given you the vocabulary, I have clearly differentiated the terms. So what falls under descriptive statistics, what falls under inferential statistics. So now what we will do, we will start our journey in understanding these terms with illustrations. So I will be giving you illustrations for each of the terms that we have studied, that we have come across so far. So the complete education would literally be rounded. So I am going to be stopping here and I will be back again.